All right, here is example 3. I started it and then I did something wrong, and so I had to cut it out of the other video and restart it. When you're doing these ones that the axis of revolution is below the x-axis, when you're thinking about c, you're thinking about how is this changing the distance. And so even though c, y equals c is -1, what we're really doing here is we're adding a distance of 1. So you want to think about this as adding 1, not adding -1. My radius has gotten longer by 1. So our outer radius, big R, is going to be the distance from the x-axis to the function, which is the 4x minus x squared, but then we have to add on the distance to the axis of revolution, which is 1. When looking at little r, it is this distance here, and that's a distance of 1, so the inner radius, little r, is 1. When we're thinking about the method we're using here, again, if I were to spin this around this line y equals -1, we end up with, again, a sort of sphere shape with a hole in it, kind of like we had in that other problem. So this is really a washer problem, because when I slice it up, it's going to have a hole in the middle like a donut would. Cool. So when we go to set up the volume, we have pi on the outside, and our bounds, since we're doing this perpendicular to the x-axis, our slices are vertical, we want to do our bounds in terms of x, so we're going from -2 to 2. And then we want to have big R squared minus little r squared dx. Now, one thing I'd like to point out, when you're setting this one up, since this is symmetrical, you could actually use your bounds from 0 to 2 and then multiply the whole integral by 2, since what's happening on this side of the y-axis is the same as what's happening on this side of the y-axis. But just to avoid confusion with those of us who aren't really ready to think that way yet, I set it up just the way we've been doing all the other ones. All right, this is your chance now to pause and finish integrating on your own, and then check and see if it matches what I came up with. And I just realized I was looking at the wrong answer key, so this is really 2 times that. So you should end up with 832 pi over 15 units cubed.